As Josh said, I work for Teradata Aster, and we are hiring database engineers as well as distributed systems engineers. So find me later if you're interested. I will be talking about a couple of features unique to Postgres and how they come together and work for a sample temporal database system to kind of see what kinds of queries we run, building a sample database, kind of how things come together, new features including DDL features that can help. And I'd like to try and adapt along the way. I haven't done too many demos like this, so I'm hoping this works out well and that there's a little bit of back and forth. And so I will try to make some reasonable adaptations along the way. I thought that this was important because one of the aspects of these features that I've developed along with the community unique to Postgres, one of the main benefits of these features is that it makes it easier to adapt designs. So we all know that at least at the low-level details of a design, they're very much subject to change, and throughout a project, everything from almost everything is subject to at least some minor changes, and that's where a lot of the bugs and problems and delays creep in. So I'm hoping that these features mitigate that immensely, and we'll hopefully see some of the ways that it makes these things less error-prone. So what I'll be talking about, this is based on the original use case that drove a lot of my work in the temporal database space. This is a little bit contrived because, of course, I don't want to develop the entire database and application in 45 minutes. But I tried to pare it down to kind of illustrate the main points that I'm trying to make, some of the features and some of the ways of looking at things that will be useful. So in this kind of sample we're working through, we'll be dealing with assets, and there's a few other kind of related topics we'll look into. But basically the idea is a company has all these kind of things floating around, some of which are valuable by themselves, some of them are valuable in aggregate. Whatever they are, but they might be assigned to a location, a person in the department, and they'd like to at least have some basic tracking of that information, of those physical assets and information about them. One thing always important to consider when working on something like this is that you need to have some concept of what queries you might be running. Of course, SQL is good, as we saw in the keynote, for ad hoc queries. You don't have to, imagine every possible query you might run, but it's a good idea to have, some idea what you might be doing with the data. And so we'll be looking at, very simple kind of tracking or accounting. There's some security issues kind of related to this, and also trying to kind of track down lost assets to avoid something. For instance, just sitting in a room for years on end because nobody even knows where it is and nobody knows that it exists. So I need to do kind of a quick primer on range types. How many of you attended the talk earlier today on range types? Okay, great. Wow, okay, that's a good majority. But I'll go through a very quick demo just to kind of for those that missed that talk, to just kind of see what they are. The idea here is that range types, hold a value that represents a range of values. So rather than holding the value 5, you might hold the value, 1 to 10, the range 1 to 10. So that's important. The other aspect is that if you're familiar with the SQL interval type, where it says something like 5 days or 3 minutes or something like that, that type is not what we're dealing with in range types. So range types, it's one of the characteristics is that it's anchored. It's got a very definite beginning point that is an absolute point and a definite absolute endpoint. There are, that could be, unbounded or infinite, but the point is that it's not kind of floating like a SQL interval. So a SQL interval of 5 days or 3 minutes isn't really anchored to any specific time that it begins. It's kind of a relative time. So I'll do a quick demonstration in the terminal here. So you start off with something fairly simple. I'll actually create a range type kind of on the fly here. Create type float8 range, and as range subtype equals float8. And this isn't there by default. There actually are quite a few types available by default, which we'll be making use of for ranges of timestamps and so forth. But just to kind of give you, it seems like most of you attended the earlier talk, so I'll just try and make this quick. But it's a, the idea is that you can do a float8 range, from 1.0 to 10.0, and you get something like that. You can do operations on that, like see if it overlaps the other float8 range from 5.0 to 15.0.
Could you possibly bump the font size?
Oh, I'm sorry about that. Let me see if I can.
Jeff, you might want to also clear the screen to get your thing up to the top.
Yeah, let me. Okay, so let's see. I can move the bottom of the terminal up. That'll raise it a little bit higher. Okay. Is that visible still in the back?
If you could make it a little bigger, that'd be good.
Okay. Let me try. Okay. So we can do kind of these kinds of simple queries. Do these overlap? And of course they do. Contains is another operation. So if one range wholly contains another, that one is false. But if you made this 6 instead, then that would be true. So this is the basic idea behind range types. You can even have an unbounded range. So in this case, if you pass a null to the constructor, it ends up being unbounded, which is not a null upper bound in the SQL sense. It's actually infinite, are the semantics. So we can be making use of that as well. I saw a question over here. No? Okay. So then let me jump back here. So this is one type we'll be making heavy use of are the range types. Then to move on to exclusion constraints, which is also something we'll be making use of. And both of these topics there could be a whole talk about, so I won't go into all the details, but just to give the very basics of it that we'll be making use of. Exclusion constraints are a powerful new constraint type available in Postgres 9.0 and later. And the main reason that this is important to Temporal is because you can specify that, like unique says that you can't have 2 users both with the name J. Davis in a system, right? It's unique. There can be only one because it's used as an identifier. So in exclusion constraints, you can specify a different constraint where it's similar to unique, except rather than looking for things that are equal in conflict, you're looking for things that overlap and are in conflict. So a schedule conflict is very commonly discussed in the business world, right? A very important use case. And so this can actually prevent schedule conflicts from ever happening in the database in a way that performs well. I'll kind of leave the details aside for now, but that's actually very difficult to do effectively without exclusion constraints. Question?
Can you express, I want no more than 3 things that overlap in this table?
No, when I,
Allow you to double book but not triple book?
no, I actually brought that up during the design phase because it would be relatively easy to do that actually, but it's a little bit. I guess the challenge is that often you wouldn't want that to be a constant. You would want that maybe driven from another table, and that actually does add quite a bit of complexity. So if it were a constant value too, then that would be pretty easy to implement. But it was basically, it was deemed a little bit too obscure and not understood well enough, what the use cases were. But if you do have specific use cases for that, and if it seems clear, I mean, from an implementation standpoint, I could do that very quickly. So yeah, exclusion constraints are kind of this more general concept than unique, and they're important for this non-overlapping, which we'll see in a temporal system is very important constraint, and that'll become pretty clear quickly. I will do a quick demo of exclusion constraints as well. Let me see, I think excuse me, just one second, this part you don't need to see. I just have the examples a little bit longer, so I'm going to copy and paste it. Okay. So, okay. So let's kind of see what happened here. I did a copy and paste just because it was more characters and I wanted to move through this, but the idea here, you can see we're creating a table. I've got, an int4 range. So this is a range, could be, values would be like 1 to 10 or 5 to 15 in there. And so the interesting part here is if you can see that constraint I put up there, it starts with exclude. So exclude using gist. That's kind of an implementation detail, but basically it's saying how it's going to index this constraint. You may know that unique constraints are internally implemented with an index. And in Postgres, that's implemented with a B-tree index always. Exclusion constraints are also implemented with an index because the mechanism is very similar to unique. But it can actually work with several different index types. And for this case, we'll be using gist. And that allows us to, this constraint to work efficiently. Really, the important part from a semantic standpoint is, the field name up here and the operator there. So the field name is, obviously referencing the field name. The operator is saying that, if there are 2 tuples, first of all, that operator is the overlaps operator. From earlier when we looked at range types, you may remember seeing the double ampersand means overlaps. So what this exclude constraint is saying is that if there may not exist 2 tuples such that the IR fields overlap, which is pretty much exactly what we want to do. So this example here will kind of show that. We tried inserting the int4 range from 1 to 10, and that succeeded. Then from 10 to 20, and that succeeded because 10.20 does not overlap with any of the existing tuples that already are in there. Then we tried inserting 5 to 15. That overlaps with the first tuple that was inserted, so it's rejected. And so that's kind of a powerful extension to unique, or not extension to unique, but a powerful kind of generalization of the unique constraint feature. And so this we can see pretty clearly how this would apply to temporal schedule conflicts. Question?
Just to confirm, the secondary value is up to but not including?
Yes.
Primary value is including, starting with and including?
Yes, by default, you can, with range types, that went into a little bit more detail in the earlier talk, but with range types, you can specify that the endpoints are either inclusive or exclusive, and I can show an example of that really quick. So for range 1 to 10. So we can see here, this is a mathematical notation. I don't know if you can see the difference between these braces in the back, but this is a square brace, and that's a round parenthesis. So that indicates that the first is inclusive and the last is exclusive. You can also specify with a double square bracket indicating that both endpoints are inclusive. Or, sorry, both endpoints are inclusive because of the square bracket. That's right. So since both, well, it is showing, but integers, yeah, integers are special, right? So with a time range, if this were a float, so let's do using my float range I just made. So now we see with float, since it's not this discrete type, then it can't normalize it to this open, the inclusive beginning, exclusive ending. So here it kind of normalized it because it's an integer range. Then, including 1, excluding 11 is the same as including 1 and including 10. Here it can't do that with the float or a numeric or something, or time for that matter. So we see here that the square bracket notation is preserved. With the exclusion constraints, kind of another aspect that we'll be making use of. Let me just run through this quickly as well, because this is one. So here we create another table bar, and what I'm trying to illustrate here is that ordinarily it's okay if in typical use cases, temporal use cases, some kind of scheduling, it's okay if two things happen at overlapping times, as long as they're, say, in different rooms, right? So here, my talk is happening at the exact same time as Dimitri's talk, and that's perfectly fine. The problem would be is if Dimitri's talk was here in this room at the same time, we wouldn't be able to understand either talk. So this is kind of an aspect of exclusion constraints that extends naturally from the semantics, which is that you specify multiple fields with different operators that mean different things. So here, kind of the interesting thing, if you see up there at the top, I can't point that high, maybe I can, is excluding I, which is just a normal integer column, with equals, right? So in that case, two values of I conflict only if they're equal. For the IR field, which is a range type, those conflict if they overlap. And only if both conflict does the constraint check fail. Question?
Did you have to install B3 just to make that work?
Yeah, I did. Yeah, actually, that's a good point. Thank you for bringing that up. I think before the demo, I had already installed B3gist. So that's an extension. It's very easy to install. You either get it from your package manager or build it from source. It's available either way. And then just the first time you use that. Sorry, B3gist. So BTREE _GIST. It's packaged with Postgres as a contrib module. Your distribution may put it in a separate package So you may have to install, Postgres-contrib package. Once you've done that, then you kind of load it in the databases individually. So you just do create extension btree gist. So that would, if it didn't already exist in my database, it would exist after I typed that command there. So basically, you do the kind of install for the for the system-wide kind of install, and then per database, you just have to load it. So, and that's a useful extension for this kind of thing. But to kind of get back to the example here, the idea is with with this, now we actually have, if you imagine I is a room number and IR is maybe some time-oriented dimension, which we'll see in a more realistic example here when I get to the database. Then you can see here that first I inserted 1 and the range 1 to 10. There's no other tuples, so of course it's going to succeed. Then I inserted 1 from 10 to 20. 10 to 20 doesn't conflict with 1 to 10, so it goes in. Then I insert 5 to 15, and that goes in, even though it overlaps. So why did it allow that one in? Because this value is different. If I insert the same one here, the same range from 5 to 15 with the value 1 again, then it finds these other tuples where 1 is equal, 5 to 15 overlaps the 1 to 10, and then you have a conflict and the constraint fails. Yes?
Is an index and just index actually created? I mean, because you did not explicitly create an index, correct? You said that you did index.
That's right. So just like a unique constraint implicitly creates a B-tree index, an exclusion constraint implicitly creates the index type required to enforce it.
So should you create a separate index?
No, you don't need to create a separate index. I mean, it can still use that index for performance reasons, So really, it's pretty much exactly like unique in that regard. So I mean, for performance reasons, if you happen to need the exact same index, then you don't need to create another one. It can still make use of it.
So you could, like in PSQL, k/needed table name, you can see the index that was created automatically. There's a notice up top.
Yeah, so you can see, so it'll show the constraint, and there is an index. It's listed under indexes. So let's see how that compares to creating a table with just int unique, and then bar 2. And so you see indexes, and then it shows it as a unique constraint in there. So it's very analogous, from that standpoint to how a unique index, works. So, yes?
If I was just looking up I, and I had only this exclude with the gist on the I and the IR, could it use a lookup just on I, or would I need to create a separate B tree for that?
It can use a lookup just on I, so I can confirm that. So from bar where I is equal to 2. So if we explain this, we'd expect a sequential scan at first, right? Oh, it's actually doing a bitmap scan already. So I guess maybe because it doesn't have stats yet, but the table's obviously small. But if we analyze, it'll probably pick a sequential scan. So it is able to use the index right away in a similar way, and that's a feature of B-tree gist and the gist index type. So it's quite full-featured. I mean, it's really been fleshed out to do anything that a unique can do.
Now, if I had done the fields in a different order, then the I wouldn't work. Is that right?
Yeah, I believe that's the case.
Thank you.
Okay, so now that we've kind of built up some context here, I'd like to jump into the example. So first, let's go make some basic tables. So we're going to have asset, person, location, department. I'll kind of buzz through these because they're pretty much as you would expect. So asset. So this table here, kind of the interesting thing about this is that I've got kind of a notion of the asset's value, but also the rate, at which you might consider it to, to be consumed, I guess you could say. So that would be if some department is using that asset. Of course, some other department can't use it at the same time. So it's, could be considered some kind of a cost, right? And so if you had a proper accounting scheme, you'd definitely be accounting for the fact that that department was using it, and you'd care how long they were using it, because if they use it for a week, that's different than using it for a year. So the assets kind of have this attached to them. And I actually included the rate as kind of two pieces, one of them being the kind of dollar value, and the other being the time over which that could be measured. Because for different types of assets, that might make more sense to use a smaller increment of time. So let me, the other tables are quite straightforward, at least these basic tables here. Okay, so location and department, they both just have one field to keep things simple. And then the person table has a salary. And now what I want to get to is the join tables. So this is a join table here. So location and occupant. So did I hear a question? Sorry. No. Okay. So the location, the occupant at that location. So the fields are pretty normal here, person and the location. You've also got a temporal attribute here, which is a time range over which they're at that location, which makes sense, right? I mean, they're in a room, so let's, imagine you're using key cards to get in and out of rooms. You're tracking that information, and you want to see where all the people are and when they were there. And they're not there for a point in time, right? You're not, you don't go into a room for 12:01 p.m. You go into a room between, say 12 noon and 1 p.m. So then we check that the lower is not infinite, right? Somebody hasn't always been in a room, so that wouldn't quite make sense. Just a simple constraint there. Then we use an exclusion constraint. Can anyone tell me what this exclusion constraint means in English?
Only be in one place at one time.
Exactly. So yeah, so it's something that simple to say should be that should be one or two lines of SQL to write. You shouldn't be writing any extensive stored procedures or any other fancy things. So there it is. So that's location occupant table. Okay, so this next one is a little bit more complicated, but not too bad. So this is basically just connecting a bunch of things together, all in one table. It's kind of a big join table. It's saying that some asset was at some location and was under the control of some department, and there was some responsible person for that asset. Of course, I'm oversimplifying a little bit here, but it's just a big table kind of saying, where the asset is, who's responsible, that kind of thing. So again, we have another similar check constraint. We have a temporal attribute here, which I call during. That's a name I typically use by convention. And then I've got another exclusion constraint. Can someone else tell me in English what that exclusion constraint might mean?
Asset can only be in one place at a time.
Exactly. So now that we have these join tables in place, then we can make the join tables. So I can load some data here really quick. It's not going to be too fancy because it's it actually gets a little bit complex to reason through if you just load a bunch of data. So I kept the data set as small as I could while trying to kind of illustrate the points. So what I'm going to do is I just want to extract the data here only, so I'm going to use the A option. Okay, so let's just take a quick look at kind of what the data looks like here. So we've got.
Need to grow that again, please.
Uh,
Try bigger again, please.
Oh, okay. Yeah, sorry about that. I'll actually do it in the other window. That I'll go ahead and load the data, and then we'll see it in PSQL in the other window. Just 1 second. So. I think okay, so I think I'd actually already loaded the data and just reloaded it, but the constraints should have kept it reasonably sane and not actually made changes here. But so anyway, so the assets that I've got listed out here are fairly simple. So everything from expensive routers to paper clips, and then if we look at from location, then we see we have 4 rooms here, a couple of labs, and a couple of rooms to work with. So the people we have to work with are here, a couple in IT, someone in finance, someone in the facilities department, and their associated salaries. And then, which one did I forget? And then, there are the departments. So what we're going to do, we won't go through the join tables. Instead, we'll run queries, and we'll kind of see how the joins come together that way. So the first query, let's do something really simple. So let's just find the average amount of time people spend in one place before going somewhere else for whatever reason. So, do they spend 2 hours in the lab, 1 hour in the lab? What do they do? So, so if we just write that query out, does somebody want to take some guesses about how that query might look? Okay. Yeah, something very, very close to that. So we're going to take the average. So we need to take the upper of the during minus the lower of the during. So let's see, casting. That could probably work. I left out. So the thing is, with the range types, I tried to make them work for many different types. So I could make that one individual cast, but range types encompass a lot of things. And so that's actually a different kind of a cast than you'd have in other range types. With time, the difference is not a time, right? With time, the difference is an interval. But with integers, the difference is an integer. So it gets a little bit interesting in the type system to incorporate that into range types proper. But question back there?
What's that going to do if one of those boundaries is inclusive versus exclusive? Is it going to bump at a microsecond?
Well, in the case of time, it's going to use what we're doing here. It's explicit, right? There's not a lot of fancy semantics because you can see that you're pulling out the upper bound and pulling out the lower bound, right? So this, for one thing right away that you might recognize is this isn't going to work very well for an empty range, you know, or for that matter with an infinite range. So what we're doing is we happen to know something about the data that, you know, we can make use of this. We could, it might be good to have a check constraint ensuring that, you know, you don't have empty ranges of time that people go somewhere. In this case, though, we will need to filter out where somebody is still in a location, right? If they've used their badge to get in a room and they haven't left yet, then there's no closing time. So this query wouldn't work. And there's no query that would really answer that very well, except maybe using now in place of infinite. But we'll just filter those out and not count that in the average because there's no reason to, you know, count in the average somebody who's kind of gone into a room for 5 minutes that might end up staying there 3 hours. Why would you be counting 5 minutes into that average? So what we'll do is select these from loc occupant and from is not for inf. Wait, hang on 1 second here. So okay, so one of some of the data is not existing there. I'm going to kind of truncate these tables again and reload the data. Sorry about that. I think what happened before is I had the data in there and then I reloaded over it and something went wrong there. So so let me try to load again. What did that happen? It's not, this is not doing the dependencies. Yeah, let me, yeah, probably a good idea. Let me do that. Oops. There you go. Now, okay, here we go. Sorry about that delay there. Hazard of live demos. So let's try our query again. Okay, so if we try this query, so again, just to get our context back, so you know, kind of upper minus lower, and then we're just kind of doing a simple aggregation. It's important to exclude those with the infinite upper bound because it indicates something that we don't really want to include in the average, and for which our simple upper minus lower calculation will not work anyway. So that was a pretty simple query. So it's basically just using range types, but it could be done without range types really, and it wouldn't be that big of a query either. So let's do something a little bit more interesting. We want to see, I guess maybe I misstated this question a little bit. Let's just make it kind of simple since the data set's small enough. See, you know, who's responsible for what dollar value in assets at a particular point in time. So kind of taking a snapshot of some particular point in time. Let's see who's responsible for what assets. So this, let me take a look here at, so here, okay. Copy this here in, and okay, so if we kind of look at what this query is doing, I didn't want to try and type this out live here to save on time a little bit. So we're getting the person ID, the person name, and the sum of the asset value is total value. But what we need to do is we need to look at a particular point in time, right? So we're not just considering now. And in fact, if we didn't have all of these predicates here, then we'd actually end up with a problem because if an asset moved from one person to another and we didn't account for the fact that it's here at one time and there at another, we might double count that asset, right? So our query might be wrong if we don't have all the predicates in place. We might be counting an asset twice, because the value stays the same as it moves from one location to another. So we don't want to count it twice. So we need, we're doing essentially a join, and we need 3 predicates. So the first 2 predicates are typical join predicates, right? We're just getting, joining on the person ID and joining on the asset ID to bring those fields in from those other tables. The interesting join predicate that you might not ordinarily recognize as a join predicate is, or actually, sorry, this is not a join predicate. This is just a filter here. The next query we'll get into a range join predicate, but this query, it's just another filter. So this here is looking at, only on March 10th, we want to find, only those assets that were in somebody's possession on March 10th. So whoever had something on March 10th, we want to know the total value, so of what they were holding. So you can see in the case of so you can kind of see the numbers here, and they make sense if you see, for the assets being held. You can see that, these two add up to 80,000, which is where we got that. One of the IT employees was holding those two. Another IT was holding something worth 80,000 directly. Then the person in finance is holding 2 paper clips and a lot of gold. So you can see how that query comes together. That's kind of a snapshot query in a way. So since it's using kind of a temporal predicate, then that's kind of a snapshot query. The next query is going to get pretty interesting because it's not going to just be a temporal predicate. We'll actually have a temporal join condition. So let's take a look at that query. Or actually, wait, is this the query? I think this might be just another. So this is actually a little bit more complicated example, but we're not quite to the temporal join. So what I'm going to do to answer this is trying to do the accounting and say, okay, you're holding this asset that kind of consumes this many resources this quickly, and so you're holding it for this period of time. So we want to account for that. So you're essentially multiplying the rate times the time, right? The rate that the asset, say, depreciates or whatever you're using, and the amount of time that they're holding it. That requires a little bit more interesting, some more interesting queries here, which we'll see. Query 3, the first thing we want to do is we'll make a function, actually. So I'm going to copy and paste this into. Okay, so here it's going to take 3 arguments: the rate per, which is the divisor. And the during, which is the kind of time period over which you are holding this asset. And the function itself is pretty simple. It looks like a lot of lines, but that's just because it's PLPGSQL. Then basically this will do some accounting if there's an empty interval, but that doesn't make a whole lot of sense in our schema anyway. So basically, it's just extracting the number of seconds from the interval you pass in and kind of using that as a divisor, and it's kind of the denominator, and then the rate you pass in as the numerator, again extracted as seconds, and then it passes that back, multiplied by the rate. So this is a little bit of extra, the kind of thing you need to work with because it's time. If we were just working with integers on some kind of magical metric time, none of this would really be necessary, but just for time, you always have to kind of make these kind of special case allowances and let the system know, semantically what you mean when you're kind of saying these things that sound simple like subtraction, or a division. They are not as well defined for time as for numbers, so you kind of have to tell the system, and that's just kind of a complexity of time more than anything else. So then once we have that function, then we'll do kind of a long-winded query here, but one that's going to be useful. So I'll go through this query. I think we're a little bit short on time, so this might we might just be able to go through this query here. So let me expand this window a little bit, and then we can kind of see what this query is doing. Okay, so we have these two common table expressions, the first being department salaries. Because for seeing how much departments consume, part of this database, I tried to be a little bit more realistic here because databases are never, quite so simple. So here we're kind of adding the, cost of the salaries, that the department needs to pay to its employees, along with the assets they're using. So I mean, at a very, very high level, right? I mean, the costs of running a business are your labor and your capital, so you need to account for both. And so that's just what this is representing. So that's a simple query, right? We're just doing a, kind of group by department sum of the salaries to get the salary information. So this one is for assets. So this is going to be to calculate the assets value that they're consuming, again, more based on kind of the time that they're holding the asset, not the value of the asset itself, but the time that they're holding that asset. This is, kind of the interesting part of this query is in here. In the middle, that's where we're calling the bill function, right, which is what we use to calculate, how much, based on how much the department is consuming based on how long they're holding these expensive assets. So what we have here is we have, first of all, we're looking at a period of time. So we're looking at this month here. So January, the month of January in 2010 is the time we're considering, and we're joining, joining assets to this wide join table of assets, location, department, and person, and then we're taking the during, and we're intersecting it. That's the intersection operator for ranges is an asterisk. And we're intersecting it with that same month and using that to pass that to the bill function. So that way, if they only used it, maybe they only used it for a day during that month, or maybe they used it the whole year. Either way, this is going to work out to be, so if they used it for the whole year, then the intersection will be the entire month. If they used it only for a day, then the intersection will be the day. So it's kind of flipping it. And then we pass that to the bill function to get that dollar value out. And then after that, we're doing the grouping, and we get the department assets. Use that, combine that by adding it to the salary amounts, because that's what we're defining as the amount of resources that a department consumes. And then there are the results. So this is kind of some of the tools that are available. I'll just kind of wrap up here, but these are some of the tools available and kind of how they fit together in something resembling more of a real temporal database. As you can see, it's pretty hard to kind of have small examples that really illustrate the benefits, but we've gotten some major benefits. So the exclusion constraints, I think that those are the easiest to see the benefits of, as you don't have the kind of mix-ups you have with double booking and things like that. That's way too easy to do, especially with a mess of timestamps. And so that's really an important feature right there, is just to kind of keep the complexity contained and keep the data clean. That's helped us a lot here. It helped me when writing this example, for instance. Caught a few errors as I was loading data. And then we can see with the queries, I mean, with some query like this, I mean, kind of imagine, writing this query here using, pairs of timestamps. Especially, you start considering, infinites and nulls and these types of things. And you're using maybe nulls and infinite. You have to do these special extra predicates everywhere. And most of you saw Jonathan's talk earlier, and so there, I mean, you can see how something that's one line here, quickly turns into 4 or 5 lines if you're using pairs of timestamps. So this is just really a difficult query to write without the benefit of range types. And then the other benefit is that this will actually perform better because you have indexes available and that kind of thing. There are even some more extensive examples that involve what's called a range join, which I didn't get to today. But the idea is where you're actually kind of matching up things from two sides. So you could imagine, people, if you had a billing application that was more sophisticated, maybe there are ranges of time over which the value, the rate of an asset changes. So, something changes in the market, you get a new contract on some futures or something. And so based on that futures contract or whatever that you're arranging, now the rate of that, consumption is now more or less valuable than it was before. And then so you'd want to, say, join those rates against the usage times, get the intersection of that, do our upper-lower calculation, multiply it by the rate applicable during that time, and then you can really do some sophisticated stuff that way. So I didn't quite get to that example, and it's actually kind of extended, so it would take a little, more involved discussion. Was there a question back there, or did I? Okay. Thank you very much. If you have any questions, please feel free to ask me. I think that this time slot's about up, but,
So if you were to want to do, say double booking but not triple booking, you do that in a trigger, and would you wind up using the ranges to do your join with that, or would that be?
Double booking. So the ranges to do the join. What do you mean by that exactly? The ranges?
I don't know. I haven't thought it through.
Yeah. I think.
Anybody would be present
Yeah.
if there was any sort of problem.
Yeah. So the range. Yeah. The range join example is kind of a little bit more extended, and just for the example of double booking, I don't think you need to quite go into range joins. Oops. The kind of constant number of times you could double book something. I think that you could probably get around that now by adding an extra field to the exclusion constraint and have it be 1 or 2, say. And so there are kind of ways of hacking around that.
Without even having to use a trigger.
Yeah. You'd have to. It would be a little bit. It might be a little bit simpler if you wrote a trigger, but there's relatively simple ways to kind of hack around that kind of thing maybe now. And if we can kind of get a use case to crystallize around what that really means, and then we can implement that, because it's actually a pretty straightforward thing to implement. And it just kind of requires some syntax, some extra syntax. If we can kind of really get our heads around that use case and what it means, then we'd be happy to do that.
I think the exclusion constraints are really neat, but they only work essentially as a test for the primary key. Practice. You can't use them for foreign keys. If you had 2 tables that had time ranges on them. So for instance.
Yeah, that may change. We may have an analog of foreign keys that's more generalized to work for this as well. That's what?
It'd be more difficult to do that. Given syntax and implementation, using index, I don't know. I've done triggers like that.
Mm-hmm.
Using, the 2 columns. It's difficult. That doesn't exist.
You mean essentially a foreign key, but a temporal analog to that? Yeah, so that can be done with triggers now to some approximation. I think you can make that mostly work with triggers now. But the syntax is not available to make that easy. I would like that to change, and I may be doing that in the near future to make that work better.
I think we need to extend the concept of foreign keys to cover all these things. We've been trying to extend foreign keys to cover arrays, and obviously we need to do the same thing.
Right. Yeah. I'd like to do that, and I think I have some sketches, but not much right now. It's just a thought. It was really kind of a natural extension of exclusion constraints that I kind of had on my radar since I did that feature. Yeah, I'd like to get this, more accepted into ORMs and other layers. So I've talked with quite a few, people that are developing those frameworks, and right now it's just hand waving at this point, but I think that better support could be introduced now that range types are here. I think that this is really the time when we can start asking them to actually implement these extensions there. Exclusion constraints and the potential for inclusion constraints don't necessarily require support because you can kind of do them behind the scenes. But yeah, we'd like support for everything ultimately.
Can I come on that real quick?
Yeah.
So I'm actually having this debate on this like PG2 list, like just supporting range types in some capacity right now. But part of it is it's actually better to try and get something like the data type at the adapter level. I mean, I know this is a whole other discussion, but like the further down the stack it's implemented, so like your native language, the easier it is for the ORM developers to integrate it. So for instance, like Ruby has a built-in range type as is. Python, it basically just maps it to a list, which is good for small things, but not good for for large ranges. So I mean, it's clearly a bigger community effort to get that adapted, but just by starting
Yeah, I mean,
somewhere.
I think just it's that sort of making sure that what we do gets passed down in a sensible way, and that's a feedback process so that we don't sort of implement something that they're going to look at and go, God, you idiots, what have you done?
Hmm.
So that's a big challenge for us to make sure we get on with.
Okay, thank you.